Hi, for our last section of Unit 8, it's on pathogens and infectious diseases. I think this is hilarious, like the germs count down to 5 before they get on something. That's just kind of funny. I can make this unit fast because we are living this right now, and I'm just going to review a couple of previous infectious diseases that have swept through different parts of the world. A pandemic. Do I need to go over this? Pathogens adapt and take advantage of new opportunities to infect and spread through human populations. And when this was made, this was just the initial spread of the coronavirus. Specific pathogens can occur in many environments regardless of the appearance of sanitary conditions. So a lot of times we connect pathogens with dirty or poor quality, and clearly that's not the case. A pathogen can spread anyway, and this is truly demonstrating that we are a global community. Climate change leads to pathogens and associated diseases spreading into new areas. So in areas where we didn't have malaria because the mosquitoes couldn't live in that area or didn't move to that area, now as we have global warming, we have those mosquitoes that carry malaria able to spread to other areas because the overall temperature of the globe is warming. So climate change does impact some of these different things that are happening with diseases. Looking at different things like ticks and mosquitoes and other things that are vectors, as the climate changes, some of these creatures are moving in into other areas and impacting more areas. Poverty-stricken areas are more often, they lack sanitary waste disposal and they have contaminated drinking water. So this all ties into our clean water and pollution. And there's a much higher likelihood for the spread of infectious disease. Wastewater itself carries a wide variety of pathogens, which are disease-causing microorganisms and viruses. So there's parasites and protozoa, fungi, viruses, prions, prokaryotes, all these different things that we know as tapeworm and malaria and athlete's foot and leprosy and AIDS. Those are all things that are spread through unclean wastewater. The plague was a bacterial infection. The infected organism bites the human or contact with the contaminated fluids or the tissues. Tuberculosis is a bacterial infection, breathing bacteria from bodily fluids of an infected person. One of my good college friends did a lot of work on TB when she was in college. Malaria is a protist. The infected organism bites the human or contact with contaminated fluids or tissues. Malaria, we typically know, is spread by mosquitoes. If you go into travel to an area that is prone for malaria, you have to take anti-malarial medication. West Nile virus, an infected organism bites humans or is in contact with contaminated fluids or tissues. So the infected bird and the mosquito. So West Nile was tied to a lot of birds, but then the mosquito was what was actually transmitting it to animals and humans. SARS, severe acute respiratory syndrome, infected organism bites the human or contact with contaminated fluids or tissues. And MERS, Middle East respiratory syndrome, it's transferred from animals to humans. And so there was some transmission there that occurred with camels. The ZIKA virus is bites from infected mosquitoes or sexual contact. So if you plan to travel to a ZIKA affected area, avoid mosquito bites is the best way to avoid exposure. And the reason this didn't become a giant pandemic is that those mosquitoes in that area was able to sort of be isolated, more so than what we're experiencing currently, which is spreading much, much quicker. Cholera is a bacteria from infected water. And so things that you can do is drink bottled water, thoroughly cook foods, peel their own fruits, be wary of ice, wash hands frequently to prevent being infected with the bacteria. And just looking at some examples of polluted water and the quality of life in other parts of the world, which definitely impacts the transmission of pathogens. So remember that over 1 billion people do not have sufficient access to safe water. That's significant. That's significant in our current situation. And about 40% of the world's population lacks access to proper sanitation and hygiene. 40%. That's a huge portion of our globe in the billions of people, almost 2 billion people that are lacking access to proper sanitation and hygiene. And think of all these things that spread in those conditions. And in sub-Saharan Africa, it's up to 64% that lack access. So that's truly significant and truly a cause that a lot of these things can spread. This is just a map looking at improved sanitation percentage, so looking at who has basically toilets, if you want to look at it for improved sanitation. So you're looking at, the United States and Canada and some countries in Europe sort of leading the way. Europe doesn't have all the data in, but we would guess that they would be mostly. But then less than 50% in India, China, and sub-Saharan Africa. So that is significant, and that's something you need to remember. An indicator species indicates whether or not pathogens are present. So we did this when we did our stream study. I'm so glad that we were able to do that, because there are things that can live in very high pollution. That worm, that Tubifex worm, the water can be highly, highly polluted, and it will still be there. So seeing that is not a good indicator of health of water. But a mayfly needs really, really clean water. And so in order for mayflies to be there, that gives us a good indication as to whether or not that water is clean. Another example is fecal coliform bacteria, such as E. coli, shows human waste has entered the water, but not necessarily the pathogen. So we can track the E. coli to let us know if fecal material has entered that water. If a species is highly sensitive to pollution, what does its presence indicate? So remember, if it's highly sensitive to pollution, meaning any little bit of pollution will harm it or kill it, that if it's present, that means that area where it's living, which is typically water, is very, very, very healthy. That was a great indicator that we used at the stream. If a species has a wide range of tolerance, will it dominate a habitat in low pollution or high pollution, and why? So a wide range of tolerance means it can live in just about anywhere, in just about anything. So if we have high pollution, it's going to be sort of the only thing left standing, and so it will dominate in high pollution.